Hi, hi, good morning. Very good morning, all of you. How are you all? Hope you're all doing well. How are you all, everyone? Right. So, here we'll be continuing our quick revision sessions, you can say, right? Today will be the last session on this quick revision of this highway. So, after this, we'll be continuing that quick revisions of this SOM, you can say, everyone. Okay? Right. So, everyone, how are you? So all of you had your tea, coffee, hot water, juice, breakfast, everything or nothing? Right. Okay. Don't worry. So we'll be having good breakfast here now. Right. Uh, this highway quick revision series will be doing, you can say. Is no? All of you, welcome to Unacademy. Let's crack it, right? Everyone, get ready to crack, all of you. Now coming to this side, these are all GATE 2024 toppers, right? Those who are secured AR1, right? Yeah, Pavan, good morning. Good, how are you? Right. So here, this GATE subscription now is available at this 8,499 rupees only, and this offer is valid up to which one? This is September 26th. Okay, this offer is valid up to which one? This is September 26th, and September 28th that new batches will be starting, you can say, right? New batches will be starting from September 28th, all of you. So what is that a referral code you have to use whenever you are subscribing to this plus and iconic courses? RP Civil is the code you have to use, you can say. Is na? What is that code? RP Civil is the code you have to use, right? Now, this 50% off on this GATE subscription, right? Whenever you are taking this GATE 2026 wala subscription for this 12 months, na, it is available at this 11,999. And GATE 2027 wala subscription, 24 month subscription, na, you will be getting this at which one? This is 17,999. Okay. So GATE 2025 subscriptions are already over. Okay, there is no other subscriptions available for this GATE 2025 aspirants. Okay, you have to be careful. But if you are taking for this 2026, right, you can go for this 2025 also, right? Now, so if you are going for this 2025, na, so this will be available at this 8,499. That is for this 6 months available, right? Okay, you have to be careful. Yeah, Sarla, good morning. Now, this Unacademy scholarship test will be going to happen on September 28th at 11 a.m. So don't miss this opportunity, all of you. So you may get which one? These laptops, tablets, speakers, and gift vouchers, and many things you can win, right? If you are performing well in this scholarship test, all of you. Okay. If your performance is well in this scholarship test, na, right, you can get all these gifts, you can say, right? And the new batches were started from 15th September. So the steel structures was started by me, you can say, at 15th September, all of you. So what is that a referral code you have to use, right? Enrollment code you have to use. RP Civil is a code you have to use, right? Steel structures I have started, and every day at 11:45 a.m. it is going on, you can say. Shikhar batch for this 2026 also started on this 31st August, right? With which one? This is steel structures by me at 11:45 a.m. only. And now, so what is it you can say? When you are taking iconic subscription, these are all the books delivered to your home within 15 days of your subscription, right? Printed books delivered to your home, right? So these printed books are having which things, right? Conceptual discussions will be there in this, and questions also will be given, right? Concept wise questions also given, and at the end topic wise questions also you can find, you can say, right? So this is my profile, you can follow me at which if you are not following. And what is the referral code you have to use, right? RP Civil is the referral code you have to use, you can see, if you just observe, right? Now we can go for this, na, as a no. So how many lectures gets over if you just observe? We have completed this 34 lectures, na, yes or no? We have completed this 34 lectures in the previous class, or not everyone, right? If you remember, so these 34 lectures are done. So this length of various roads as per this third 20-year road plan we have seen, right? So these are all which one? This highway development activities we have seen, isn't it? Yes, no? So these are all the institutions, right? Next highway classifications we have started, right? Isn't it? Got it? Urban roads and rural roads classification, right? 365 points gets over na? So no, 365 points gets over, you can say. Now we'll be discussing this 35th lecture. So highway quick revision 365 na? So no, now 367th point we'll be going for. 367th point, right? Now tell me, if you just observe, right, what are the different things we are supposed to discuss, right? These extra topics, if you just observe, right, in these extra topics, right, what are these extra topics you'll be having, tell me? So they will be having concepts related to this payment, you can say, right? One is, which one we are missing, if you just remember? Which one we are missing, if you just remember, all of you? So the concept ones, okay. Right. So Indian Road Congress and everything, right? First 20-year road plan, the second 20-year road plan, and all these things are over, na? Is that no? All these things are over or not, right? So National Road Transport Policy, right? Everything is also over, na? Is that no? So here there are a few points we are missing, right? What is it, you can say? National Highway Authority of India we have discussed or not? Is not? Okay. Highway development is also over, and this planning is also over, na? Is that no? Next we will be going for which one? This group index wala, and these extra topics, if you just observe, right? Yes, now whenever you are going for this group index, triaxial test method, right, Burmister's elastic layer theory method, right? So these methods are there for which one? This ESC, na? Is that no? Mostly, and for the state examinations also they will be available, you can say, right? Is now okay, we'll just go for this, you can say, right? So what is that we'll be having is Burmister's elastic layer theory, okay, these extra topics. So whatever are missing topics, right, we'll be discussing all these topics here itself, okay. Burmister's, if this class is not sufficient, I'll take one more class in the October starting, okay. Burmister's, arey yaar, what happened? It went away suddenly, it's gone like that. Okay. Burmister's elastic layer theory. So for which one? This is a flexible pavement design, na? Arey kya yaar, what happens here? If I'll go to this top, it is happening like that. It is for which one, if you just observe, this flexible pavement only or not, right? Flexible pavement only, you can see, if you just observe, right? Now here what are the different layers we are having, tell me? I'm not going to explain the assumptions and all these things, right? So this is your surface course we are having. This is your after that, right, surface course, right, what is it, you can say, base course we are having. After base course, right, what is that next layer? Is sub base course, and below that, right, what is it, you can say, that subgrade soil is present, you can say, right? And the loads will be applied through this in this manner, na? So that P will be your which one? Wheel load, you can say, right? That P is that wheel load, you can say, right? Now tell me, here if you just observe it, elastic modulus, right? So here it will be the elastic modulus, or this Young's modulus of this base is EB, elastic modulus of this sub base is ESB, elastic modulus of which one? This subgrade is ES, right? Now tell me, which elastic modulus will be higher, right? Which member is stronger, you can say, if you just observe, which one is stronger and whose elastic modulus will be higher, you can say. That elastic modulus of this base will be higher than this, elastic modulus of this sub base will be higher than this elastic modulus of this subgrade, na? Isn't it? Got it? Now here if you just observe this, right, what is that vertical surface reflection you have to consider, tell me? That vertical surface reflections, right, how can you consider? So there are flexible plates, or this rubber plate you are having, and what is another plate, you can say, that a rigid plate or this mild steel plate also you will be having. So here in that, right, vertical surface deflection, that delta is given as your which one? This 1.5 into that P into that A by which one? This E of which one, you can say, E of this subgrade, na, into what is that, you can say, that F2, if you just observe, right? So what is that F2? Okay, so don't worry, right? And here what is that, you can say, if you just observe that delta will be equal to, or either you can use this formula. Yeah, yesterday one question we have discussed all these things. PYQ session, yes, Pawan, correct. So this is 1.18 P into that A divided by which one, this ES only na, that ES into that which one, this F2. Okay, same. So here when we have to use this first one, tell me, whenever it is that a rubber plate we are using, we have to use this na, rubber plate or this flexible plate you can say. And when we have to use this second formula, whenever you are using this MS plate na, that mild steel plate or this rigid plate, we have to use it na. So mild steel plate or this rigid plate we have to use, you can say, right? Now how can you calculate this F or this F2? F is nothing but your F2 calculated based on, right? That is important, right? Calculated from which one, tell me? There are two parameters, right? What are the two parameters? A by this H1, right? So A by this H1, and what is that, you can say E1 by this E2. A by this H1 and E1 by this E2, right? What is that E1 by this E2 and A by this H1, you can say, if you just observe. Anyone having idea? What are this E1, E2, you can say? That E1, E2 are which one? So if you are considering any two layers, na, right? If you are considering any two layers, na, right? What are the two layers, you can say, if you just observe? These are the two layers if you just observe, right? And here the load is applied on which layer? Top layer, na? The load is applied over this top layer, right? What is it, you can say, over how much contact area, right? Over the radius of relative stiffness, that okay, sorry. So here it is radius of loading area, right? Radius of loading area means it is the complete plate dimension diameter is A, or the plate radius is only taken as A, you can say, if you just observe. So this plate radius is only taken as this A, na? So this is A, right? And this particular top layer thickness is H1, and this bottom layer thickness is which one? This is H2, you can say, right? So, and what is that elastic modulus of this first layer is E1, elastic modulus of this second layer is E2, right? So whenever you are taking the combination of these two, right? So what is that? SCBC you are taking, and BC SBC you are taking, and SBC and subgrade soil you are taking, right? Yes, na? So like this we are taking, right? It is a general formula, you can say, right? Okay, yeah, Supriya, good morning. This is a generalized formula, you can say, right? From A by H1 and this E1 by this E2 you are getting, right? A by this H1 or H1 by this A by this H1 or this H1 by this A, you can say. Okay, some curves are there. I will be just drawing a curve. Just briefly, roughly I will draw the curve, right? Burmister's curves are there, right? Note these points and tell me, everyone. Once these are noted, I will move on to that next. So that F is called as your deflection factor. F or this F2 is called with which name, you can say? That is called as your deflection factor. So everyone had your tea, coffee, hot water, juice, breakfast, everything is over or not? Right. I think it is giving add now. Noted? Once noted, tell me. I'll just try to move forward. No, not yet done. Right. So what is the total thickness of this payment? If you just observe that the total thickness of this payment is given as your H, na? Yes or no? Total thickness of this payment is given as your H, right? Yes, na? Total thickness of this payment is given as H, right? Once noted, tell me, everyone, this one. Is it done? Done? Okay. So this formula we have to use, right? A by h1 or this h1 by this a we have to use. Now here, right, how can you use this if you just observe this is your 367? Okay, how can you use this if you just observe? You can say, how can you use this if you just observe, right? This is how the curve, again when I am writing at the top it is going off. Right, so here if you just observe, this is how you will be having these curves, you can say. So on this x-axis, that h by a will be there. On this y-axis, right, what is that? Yeah, daily routine, I told you, na? I woke up at 5 o'clock and I did brushing and everything. And 6 o'clock I was just leaning on sofa. And 6 o'clock I went there and slept up to 7 again. 1 more hour. Like that. Okay. So here what is that you can say, right? We will be having this, no? So this is how the curves will be there, right? So what are these curves representing? If you just observe, these curves are representing that which one? This E1 by this top layer Young's modulus by this bottom layer Young's modulus, right? So that is equal to 1, that is equal to, sorry, that is equal to 2, let us say, that is equal to 5, let us say, that is equal to 10, right, like that. So from top to bottom these values are decreasing, right? Here if you just observe, what is that you can say here? 0 will be there, 0 will be there, and what is that you can say? 0.2. Yeah. So this is your which one? This is 0.5 and this is your which one? This is 0.9 will be having. It's not again. So like that will be having. Now here based on this, so you can get this, right? You know this h by f, right? Based on this h by f or this f2. So what is the f2? We have to take it. You can say if you just observe for the first one. At pavement surface, first we have to get na SN. One sec. At pavement surface, right, what is that f value comes to be if you just observe? So if you are going for this at pavement surface, whenever it is the surface of this pavement, right, at this pavement surface, right, what is the h by a? Tell me that h by a will be 0 and this f2 will be equal to which one? This 1, na? Yes or no? Now get what you can get. Tell me, you can get this E2, na? Yes or no? You can get this E2 from here, right? Yes, na? So F2 we know, H by A we know, corresponding to the surface, right? Its surface who will be there? Plate only will be there, na? Yes or no? Plate only will be there, right? H by A is 0 and F2 is 1 and get, you can get which one? This E2, right? E1, Young's modulus of this plate we know, right? Yes, na? You can get this E1, right? Because E1 by this E2 is there, na? E1 by this E2, right? E1 is nothing but your plate Young's modulus, you can say if you just observe, right? Is not? E1 is nothing but your which one? This is a plate Young's modulus, right? Or if you just observe for this plate, right? For this plate, what is that you can say? So whenever you are having this, right, that plate height will be there, na? So whichever the thickness of this plate we are using, that you know na, when you are testing, isn't it? This A is that loading area, and what is that you have to consider? Tell me. This is taken as your plate, right? This is taken as your plate, right? This is your subgrade, and what is this you consider? That is your Young's modulus, right? So now for this subgrade, if you that is for plate. Next for this subgrade, what is it we need to do? H by A will be having, and Young's modulus of this plate by this Young's modulus of this subgrade, right? So is na Young's modulus or elastic modulus of this subgrade we know or not? Young's modulus of this plate or this Young's modulus of this subgrade we know or not, right? ES we know na from this plate load test, is na? ES we know. EP we know na? Yes or no? EP also we know or not, right? EP also we know, right? Because this is elastic modulus of which one? This plate, you can say, right? Elastic modulus of this plate we know, right? Because which material we are using? Rubber material or this mild steel material we are using, from that elastic modulus of this plate we know, right? H by A, right? That thickness of this plate we are using, right? A we know, right? Is na? These are all the things we know na? From these, right, what is that you can get it? Tell me. Based on these values, right, what is that you can get it if you just observe it? Can't you get this F2 value? Can't you get this F2 value for this payment if you just observe? Yes, we can get this F2 value for this payment, na? Yes, no, we can get this F2 value for this payment, you can say if you just observe, right? Isn't it? Is no? Right? So if we just observe this procedure, right, what is the procedure we have to follow, right? a representative pavement thickness of how much you can say pavement layer of this convenient thickness H is laid on the subgrade, right? Will be, and we need to conduct a plate load test over this, get P1 A H delta 1 and F2 will get it. Okay, after getting them, right, what is it going to do? Select the curve based on this E1 by E2 ratio, right? Based on this E1 by E2 ratio, right, select which one this curve, right? Is not, and corresponding to this F2, select which one this H by A and get H. Okay, corresponding to this E1 by this, corresponding to this F2, right? F2 only unknown na here. Once you know this F2, you can substitute everything in this formula, na? Yes or no? You can substitute in this formula and you can get all these parameters or not, right? Yes, na? Is it like that? So this is how will be going for which one you can say? This is how will be going for which one you can say? Just observe which method will be going for. That Burmister's elastic layer theory method we are going for, na? Yes or no, like this? Burmister's elastic layer theory method we are going for, you can say just observe, right? Isn't it clear? Now, this is your 367th point. Now, this is 368th point, you can say. What is this 368th point if you just observe? So, here this is 368th point, right? Okay, that F2 we will be getting, na? Yes or no? A you can get it, na? How can you get this A? Yeah, finally our target is to find which one, you can say our target is to find that H, na? Yes or no? Finally our target is to find that H, you can say, right? So if you want, I'll be sending an example question on this. I will send an example question on this, you can say. Just text me. Okay, but okay, we will not be solving that example question here, right? Now next one, California resistance value method. After getting this F2, you substitute everything in that and you will be getting which one? This is thickness, na? Yes or no? Thickness you will be getting, right? That is what. Here all these formulas are there, na? Yes or no? See, these graphs are there, right? If you just observe, right? These graphs are there, right? H by A value. See, F2 value you found, na? From this F2 value, right? What is that we need to get? Get H by A. Okay? Get H by A. So, this F2 we have calculated from the known. So, the plate parameters are known and this subgrade parameters are known. Na? Keep the plate on the subgrade and for this subgrade you get this H2. Okay? For this subgrade you get which one? This F2. Yes, na? So, plate and subgrade you get this which one? This F2. Right? From this from that you can say, right? From which one? Right? From this equation, right? Because delta we know and pressure applied we know and area we know and Young's modulus of this subgrade also we know, right? From this we can get this F2. Now do you have any problem? Yes, F2 will get it, right? Now after getting this F2, right, what is that we do? Now consider this subgrade and the total thickness. Instead of a plate, what is that we need to consider? Total thickness you consider. You remove the plate and total thickness of this pavement which we are going to construct in future you consider. That thickness we are going to get. Do you know that? We do not know. And F2 already we know for this subgrade. When you know this F2, right, and E1 by this E2, right, E1 by this E2 you try to get it, right, and chose the curve, right? Let us say this is the curve, E1 by this E2 value satisfying that, right? Top layer by this bottom layer, right? Now tell me, so we are thinking now that pavement layer will be having that much amount of which one? This that much amount of this Young's modulus it should have. We will be estimating or not, right? Yes, estimating, right? Now, so corresponding to this F2 which we have opted, and select that E1 by E2 curve and get which one? This H by A value, right? From this H by A value, can't you get this thickness? Can't you get this thickness? Yes, you can get this thickness if you just right. Is it clear now? Is it clear now? So finally, from known values you get the unknown values, and from the known values again you get the thickness. That's it. Is that? Is that it? Go forward, backward. Go forward, backward. That's it. Nothing else. Okay. So California resistance. Arre Baba. Why it is happening like that? If I am crossing that line, na? California resistance value. A is known, so we get H. Yes, that is what absolutely right. This is also called as which one? This is McLeod method. Okay. So here it is based on which values you can say. There are two experimental values we are having, right? Yeah, 0 is helping us, right? 0 is helping us, right? So now tell me, right, what is it we need to go for? That depends on which values, tell me. This depends on stabilometer R value, right? So that R is obtained. There is a constant called as which one? This R. So stabilometer R value, right? What is the meaning of this stabilometer R value, right? That there is a constant R which is obtained from this stabilometer experiment, right? But don't worry about this, right? You will not be asked how to do this stabilometer experiment and how to get that R value, right? So they will not go up to that much depth, right? Simply you remember that from the stabilometer experiment we will be getting that R value, okay? Now 𝐂𝐨𝐬𝐿 which value? C value. So there is a C value obtained from this 𝐂𝐨𝐬𝐿 test, right? How can you determine these R and C? These are determined from which one? This experimental is na RC, right? So Royal Challengers, Ram Charan, whatever it is, right? So here we will be having some values, you can say, right? Some equations if you just observe, right? So that what are these equations, right? Total thickness of this pavement, right? Our final aim is to find the total thickness only, no? Yes or no? Total thickness of pavement we have to find out or not, right? Total thickness of pavement if you just observe. So what is the total thickness of this pavement? That a capital T is the symbol we are giving, right? So that a capital T will be equal to which one? This K into Ti into, right? What is it? You can say that a 90 minus R divided by which one? This is C power 1 by C power how much? Anyone remember this? C power 1 by 5. Okay? C power 1 by 5 you can say, right? So this is the formula. Now here what are the known values and what are the unknown values? Tell me from here if you just observe. This is equation number 1. Na? So what are the known values and what are the unknown values if you just observe? So that K will be which one? This? It is a constant, and if nothing is known, right, how much we have to take it? 0.166 is not 0.166, right? It is which constant you can say? That is your numerical constant you can say if you just observe, right? So this is by default we have to take it. So tell me which parameters are known? That R parameter is known from the stabilometer experiment, C parameter is known from the 𝐂𝐨𝐬𝐿 experiment, and which one are unknown? K and Ti are unknown, na? So no, Ti is nothing but your traffic index, right? So K constant we know, right? 0.166, right? This is numerical constant by default. If nothing is mentioned, you take it as 0.166, right? Now what is that Ti? You can say if you just observe, that is your traffic index, right? What is it? You can say that a traffic index, that a Ti will be equal to how much you can say? 1 point, which one? Yeah, yes, right? K into, right, it is Ti, traffic index, right? It is a traffic index, right? A Ti will be equal to which one? This 1.35 into EWL, right? What is that EWL? You can say equivalent wheel load power 0.11, right? Equivalent wheel load power which one? This is 0.11 you can say, right? So now this is the traffic index formula. Traffic index you can get it from here, right? And if you wanted to get this traffic index, we should know this EWL, na? So what is that equivalent wheel load? Equivalent wheel load average. How can you get that? So equal EWL is nothing but your equivalent, which one? Equivalent wheel load, which value? Average equivalent wheel load, na? EWL is nothing but your, right, average equivalent wheel load. You have to consider this, right? As na average equivalent wheel load we have to consider, right? That EWL. Okay, note this and tell me. So then if you are substituting that, what is that you can say? Substitute this equation number 2 in 1, then you can get some other equation for this Tina final expression, right? Yes, na? So how to get that equivalent wheel load? I'll just make which one a tabular format and I'll tell you. Okay, don't worry. So that you can understand how to get that equivalent wheel load from the given data. K directly you are taking. R and C experimental results, right? So they must be given in the question. TI only we have to calculate based on the equivalent wheel load. If you know how to calculate the equivalent wheel load, then it's over now. So anything else is required? Nothing else is required. If you know equivalent wheel load calculation, just that thickness calculation is over or not? California resistance value method, isn't it? Right. So if you are observing here, substitute 2 in 1. So from this 1 and 2, right, what is that you can get it if you just observe that a total thickness capital T will be obtained as 0.22 into, so I am writing the final expression after substituting and simplifying everything, right? 0.22 into that equivalent wheel load power, which one? This is 0.11 into, yes, no? In place of this, so K value 0.166 we have to substitute. In place of TI 1.35 into we have to substitute, right? Yeah, if okay, but these are easy only. Now many people don't study this one, right? Many people don't even know that these formulas are there, right? Yes, na? So it is better you have to go for this, right? It is better you study and you you expect that they will be giving this question so that you can solve and you will get marks. Okay, so now if you just observe that a T1 by this T2 will be equal to which one? This is C2 by this C1 whole power this 1 by 5 na? Sorry, this is 1 by 5, right? 1 by 5 means 0.2. Okay, isn't it? Isn't it? Now how to get this value? Tell me. If you just observe this EWL calculation, right? That EWL equivalent load calculation, if you just observe, what is it you can say? Here that tabular data is given. What is it you can say? Number of axles. Okay, this is your number of axles you are having. Number of axles you can have. So number of axles, some 2 3 something like that they will be giving, right? So now what is it they will be giving? Tell me. AADT they will be giving, yes na? Yeah, this is AADT they will be giving, right? AADT some 300, okay, some 4500, right? Like that you'll be having, right? So simply what is that equivalent wheel load, right? Simply that equivalent wheel load is nothing but your AADT into, what is it you can say? Equivalent wheel load, right? What is it you can say? Equivalent wheel load constant, right? Equivalent wheel load constant, right? So what is that equivalent wheel load constant? You can say if you just observe. So this is equivalent wheel load constant. Okay. So how can you get this equivalent wheel load constant? You can say if you just observe. 2 axle, 3 axle, 4 axle, 5 axle, 2 axle, 3 axle, 4 axle, 5 axle, right? Maximum 5 axles only will be having. So for this 2 axle, how much it will be? That 300. For this 3 axle, how much it will be? 1070. And for this 4 axle, how much it will be? That is your 2460. And for this 5 axle, how much it will be? 4620. If you just observe, right? 4620, right? So these values we have to, which one? This remember. Okay, these values you have to remember, right? So AADT values we know, right? Instead of this number of axles, that equivalent axle load constant we have to remember, right? It's not 2 axle 300, 3 axles 1070, and 4 axle 2460, 5 axle 4620, right? You have to remember these values definitely, right? You have to remember which one these values definitely you can say if you just, right? Isn't it? Now this is what you are getting now. Yes or no? This is what you are getting, you can say, right? And these summation, right? What is it you can say if you just observe? This is your equivalent wheel load will be equal to, so this is your first column, this is your second column, this is your third column, right? Which columns we have to multiply? That is second column and this third column we have to multiply now. So you calculate that equivalent wheel load, right? Equivalent wheel load. This is for which one? This 1 year you will be getting. This is for which one you will be getting? Some value you will be getting here na. That is for this 1 year you will be getting, you can say, right? That is for this 1 year you will be getting, you can say, right? Isn't it? That is for 1 year. Okay, 1 year means starting. This is starting. Okay, note this and tell me. So this this equivalent wheel load value at starting value, how can you get that? Is it clear, everyone? So that for 1 year means first year. Okay, not 1 year, first year. So equivalent wheel load average we have to get it now. So equivalent wheel load average we have to substitute here, right? How will you substitute that average? That is important, right? Initial value, first year value, and nth year value. If the design period is 15 years, next we have to get it for the 15th year, and first year plus 15th year value of EWL by 2. That is how we have to get this EWL. Is it clear now? So this much story is there. So once this is noted, tell me. I'll go for this next. EW constant values we have to remember, right? EW equivalent wheel load constant for 2 axle, equivalent wheel load constant for this 3 axle, equivalent wheel load constants for this 4 axle, equivalent wheel load constant for this 5 axle. So these values you have to remember, right? These are the standard values, you can say. Okay, these are the standard values. Okay, now so what is it, you can say, for a design period of n years. For a design period of which one? This n years. Arey baba, what is happening here, yaar? For a design period of which one? This n years, you can say, right? With some how much, you can say, x percentage increase. With how much increase, you can say, with x percentage increase. Now tell me that equivalent wheel load at the end of this n years. Tell me nth year. What is it, you can say? Equivalent wheel load over this nth year. If you just observe, tell me. This is for this nth year. How can you get this for this nth year? You can say this is 1 plus which one? X percentage increase na. So that x percentage by this 100. So this many times, right? What is that, you can say, if you just observe that equivalent wheel load for this first year na. Equivalent wheel load of this first year you are getting na. So no, equivalent wheel load of this first year power how much? That n. This power which one? N, you can get it, right? This is nth year value you are obtaining, right? So now tell me, how can you get this equivalent average, equivalent wheel load average? Tell me. What is the equivalent wheel load average? If you just observe, tell me. Equivalent wheel load average is nothing but your equivalent wheel load for this first year plus this which one? Equivalent wheel load for this nth year divided by which one? This 2. Isn't it? Is it clear, everyone, right? How to obtain this equivalent wheel load for this years? Is this clear? That California resistance value procedure is clear, everyone? All of you? Clear, all of you? Hello? This California resistance value procedure method, it is clear or not? Somebody respond. Pavan, Supriya. 368. Are you there or not there? 369 if you just observe, right? So what is it, you can go for this triaxial. What is it, you can say? in this triaxial test method, right? What is in this triaxial test method? You can say, if you just observe that a thickness T will be equal to how much? You can say that a thickness T will be equal to under root, what is that? You can say this formula here done, 3p by this 2 delta es whole square minus which one, this a square, right? That is your total thickness, na? Total thickness of this pavement. So what is that P? You can say P is nothing but your wheel load, na? Yes or no? P is nothing but your wheel load or not, right everyone, right? P is nothing but your wheel load, you can say. And what is that ES? You can say, if you just observe, ES is nothing but your elastic modulus, na? That is your elastic modulus of what? Elastic modulus of which one? This is subgrade soil, na? Elastic modulus of this subgrade soil, right? P we know, ES we know. And what is the A? Radius of this contact area already we know, right? So now what is the delta? You can say, if we just observe, that is your design deflection. Okay, that is your design deflection. You can say generally, if nothing is mentioned, how much we have to take it? That 0.25 centimeter is the maximum deflection we are allowing, na? So no, that we got to say, right? So if nothing is mentioned, we have to take it like this. Is it clear? Once clear, note down and tell me. Noted? Now 370th, right, group index method, right, we'll be going for, right? What is it? You can say that the 370th formula, group index method for the calculation of this thickness of pavement. So whenever it is that group index, right, how can you get this group index value? If you just observe, why nobody is responding? 0.2a plus which one? This is 0.005 AC plus which one? If you multiply the 0.005 AC plus 0.01 BD, okay? So this is how we'll be getting this group index or not? If you remember, of it, this is how we'll be getting this group index, na, right? What is the A? You can say percentage of soil passing what? Tell me. Passing that is 74 micron in excess of what? Tell me. In excess of which one? This is 35%, right? And not greater than 75%, na? And it is allowed to have greater than 75% or not greater than 75%, right? Not greater than 75%. What is the B? You can say same percentage soil passing which one? This is 74 micron in excess of which one? This in excess of this 15%, and not exceeding which one? This and not exceeding that 55%, right? This group index calculation, do you remember everyone? So what is the C? Liquid limit in excess of what? 40%, right? In excess of 40% and not exceeding which one? And should not be greater than this 60%, right? And what is the D? You can say that is your plasticity index, na? So no, plasticity index in excess of which one? This 10%, right? And what is that? You can say it should not be exceeding this 30 if you just observe, right? Isn't it? Is it clear? So this is how ABCD values are obtained from this soil grain size distribution analysis, right? Grain size distribution analysis, right? From this grain size distribution analysis, right, what is that we are going for? We will be getting this group index value, right? So it's now from this group index, right, what is it? You can say so that group index standard values will be there, and this thickness you will be having, you can say, is now thickness values in the thickness values of this pavement in the centimeter are there, group index values are there, right? So from this you can get this thickness, na? From this you can get this thickness, you can, right? Like that. Is it clear, everyone? Right? So that is how we'll be applying these methods, you can say, if you just observe, right? Yes, na? Right. Like this we'll be having. Okay? So I'll be ending the session. Thank you all of you. Have a good day with this highway completed. So next today is 24th, na? On 26th we'll be having that SOM quick revision, right? SOM quick revisions will continue alternate days. Okay? Thank you.